In pre-cal, we're learning about exponential functions. Exponential functions and logarithmic functions, and they have a million applications in both scientific fields and a variety of others. We're going to talk more about that as time goes on, but today we're going to just get kind of the basics out of the way. So we're going to start with the definition of an exponential, and the exponential function with base a is a to the x, f of x equals a to the x power, where a is greater than 0, a does not equal 1, and x must be real. So it must be a real number as opposed to being maybe an imaginary, which is what we've talked about before with the complex numbers. The x has to be a real number. Okay, the first thing we want to learn how to do is to evaluate some exponentials using the calculator. So we're going to practice doing that. The main thing here that's different or that you want to watch out for is the fact that you really need to be careful with your parentheses. If you get the parentheses wrong on this, it is going to cause you some significant problems. So you'll get the wrong answer, so watch out for that. Example number 1, f of x equals 2 to the x power, where x is equal to negative 3.1. So what we're going to do is we're going to go to our calculator, turn it on, do 2 raised to the negative 3.1 power, and we get a value of 0.116 or 0.117. And that's it. That's our answer. Let's try another one. If I do f of x equals 0.6 to the x power, where x is 2/3. Here's where it starts to become real important for me to put that in parentheses. So I do 0.6 to the 2/3, and it's 0.711. Nothing overly complicated about that. Again, just watch out for those parentheses. Also, some people on the homework were confused. There's a problem where it has something here and here that's being multiplied, something here and here that's being multiplied. Be sure that you're doing this to this power, these things in parentheses. When you multiply them, you'll see what I'm talking about when you get there. And then multiply by this number, or put in your calculator straight in there. Just watch your parentheses. If not, you're going to get an answer, or in your calculator may even say overflow, as in it won't do the problem for you. So watch out for that. The next thing we want to talk about is how to graph these things if I have f of x equals a to the x power. And in particular, we're going to try and sketch 2 to the x power and 4 to the x power on the same graph. To do that, we could pick some points and plug them in. So I'm going to make two x and y charts. The first one for 2 to the x power, the second one for 4 to the x power. If I choose some values, I'm going to choose negative 2, negative 1, 0, 1, and 2. And I'm going to do the same for both, so I'm comparing apples to apples here. And the reason I'm choosing those is so I can have some negative values, 0, and some positive values. Now, to speed this process up, I'm going to use my table function. But if I wasn't, I would do 2 to the negative 2, 2 to the negative 1, and I would have 0.25, 0.5, on and on and on. Again, to speed that up, I'm going to go to my y equals and put 2 to the x power and 4 to the x power. And I'm going to go to my table, and I can fill in my values from there. So negative 2, 2.5, and on this one, 0.0625. Negative 1, 0.5, and 0.25. 0, 1, and 1. 1, 2, and 4. And when x is 2, my values are 4 and 16. Again, that's just to speed up the process there. You do not have to do it that way. You could plug them in each one and go from there. Okay, now that we've done that, we want to graph these. 2, 4, 6, 8, 10, 12, 14, 16. I'm going to go by 2's on my y-axis so that I can get to 16 eventually. If I plot these, I have negative 2, 2.5, negative 1.5, 0, 1, 1, 2, and 2, 4. So this is my graph for 2 to the x power. If I do 4 to the x power, it's 0.065, 0.25, 1, 1, 4, and 2, 16. You'll notice that this one goes up significantly at a faster pace because our base is higher. Think about this. If your base was 8, it'd be even closer to the y-axis here, something like this. If it was like a half, it'd be something like this. An important thing to realize is they both go through the point 0, 1, which is a property of exponential functions unless there is a transformation, because think anything to the 0 power is 1. So that, in general, this is what the shape of that graph looks like. The last thing we want to talk about is the transformations of these graphs. And this should be mostly review for you because it's the same properties that we've been following all along with our transformations. So let's just take a few examples. Example 4, f of x equals 3 to the x plus 1. Remember, anytime there's a plus 1 or a minus 1 with the x, that just tells me that it's shifted left or right. In this case, it is shifted left by 1. Example 5, if I have f of x equals 10 to the x power minus 2, notice the minus 2 is a big minus 2, so that one tells me that it's shifted down by 2. Remember, a minus or plus on the end is up or down. Example 6, if I have f of x equals negative 5 to the x power, and negative out front tells me it is reflected. And remember, in front is over the x-axis. This becomes real important here, guys, the x or the y, because in this case, unlike at the rational functions, it does matter x or y. So this one is over the x-axis, which means you should be asking me the question, well, what happens to make it flip over the y-axis? So let's look at one like that. If I have f of x equals negative x minus 3. Notice that both of these pieces have a negative. More importantly, notice that there is a negative in front of x. To solve this, I've got to distribute out or pull out the negative, factor out the negative here, and what remains is x plus 3. The reason that that is so important is because unless you've taken the negative out of all of this, you won't be able to see correctly whether this is left or right. In this case, it's going to be left 3 and reflected over the y-axis. So reflect over y and left by 3. Let me also make a note here that if this was negative x plus 3 here in the beginning, I would still take the negative out, but then this would be x minus 3. Okay, so that's pretty important there. That's our answer. Your homework is very, very similar to this. It's A2, it's page 226, and it's numbers 2 through 26 evens only. On a lot of this, you will be using the calculator. If you have other questions, be sure to let me know when you're in class next.